All right, we're back. We are on page 2 of notes 22 of Calc AB. We're talking about density functions and integrals and how they can tell us the total number of something. So there's kind of like a paragraph here that sort of talks about it. Previous page, every problem that we did 2 of them. They were pretty simple. Like I think maybe a 5th grader probably could have answered them because the density was constant and you just had to be doing kind of like a dimensional analysis type of thing, right? Like make sure the units work. If the units work, you're getting the right answer. We want to deal with calculus, and in calculus we'll have densities that just vary. So like, why might a density vary? So I mean, one common thing is that more people live closer to cities. So as you get farther from a city center, you would expect the density of people to decrease. So the density is going to be a function of distance from the center of the city. That's pretty common. Another common thing is more people tend to live by water on the coasts of things, right? So the density would vary as you get farther away. It would be decreasing as you get farther away from the water source. So let's see if we can work out how to do a problem where the density varies. So a city located beside a river has a rectangular boundary that is 4 miles by 7 miles as shown. So this is 4 miles, this is 7 miles. So I'm just gonna kind of like indicate that. So this total here is 4 miles. We're gonna have to come up with some sort of coordinate system eventually, but you know, for now, 4 miles by 7 miles. The population density of the city at any point along a strip X miles from the river's edge, so from the river's edge, is f of x people per square mile. What we want to do is come up with a definite integral that gives the population of the city. So the way that I do this is I take the picture and I slice it up. And after I slice it up, I find how many people live in each little slice. And then if I can figure out how many live in each little slice and add those up, it should give me approximately the number of people in the city. So that's what I'm going to try to do. So let's see if we can do this. So we're going to start by drawing a strip along which we'll find the population. So I'm going to, so the density varies as you get farther from the water, right? So I'm going to say that this is X, and then this is Y, but Y is always going to be 7. So I'm going to slice this up into a bunch of rectangles. So here, and then, so we're gonna have like delta x's. I was kind of hoping it would be like, yes, all of us are the same, but it didn't do that. Okay, so whatever. Let's pretend that all these are the same. They're definitely not. I'm gonna call this delta x, delta x, delta x, delta x, and delta x. All right. So now what is the area of each? So I have these little strips. Each of these is a strip. People live in each strip. Right? So here's one, and there's some number of people living in that strip. And then here is a second strip that has an area. And within that area, there's a certain number of people who live. It's less, probably, because the density changes as you get farther from the water. Here's another strip. It has an area, but what's the area? So the area of this should just be delta x times 7, right? And here's another strip, and it has an area, and then a certain number of people live in this. So this has an area of delta x times 7. And then finally, we have another strip that has an area of delta x times 7. So we have a bunch of strips that all have area delta x times 7. So the area of a strip is going to be 7 times delta x. So now the question becomes like, what's delta x? Well, I think delta x is going to be 4 divided by 4 divided by the number of strips that we decide to make. So 4 divided by n. I think that's going to be delta x. So this has an area that's in, this is in miles, and this is in miles. So the population, the density, people per square mile, let me highlight that, f of x people per square mile. So how many people live in the strip? People in the strip going to be the area of the strip, which is in miles squared, 7 delta x, times the density, which is in people per square mile. We have to have like an x sub I there. So that's the people in one strip. So this is miles squared, and this is people per mile squared. So now if you wanted to be a little more formal about this, I guess, delta x, we're looking at 4 over n, and then x sub I, let's say we do a right Riemann sum, right? So if we're going from the river to 4 miles out, let's say it's 0 to 4. So then x sub I is going to be 0 plus I delta x, or just 4i over n. So that's the number of people. This is the total number of people, because we do miles squared, people per mile squared gives us people. So now what we want to do is we want to sum from I equals 1 to n. I'm going to rearrange it a little bit. So I'm just using, I'm just using this. I'm just going to rearrange it to put the delta x at the end. So 7 f of x sub I, 7 f of x sub I delta x. This will sum up all of them. But what I really want to do is the limit as n approaches infinity of the sum from 1 to n of 7 f of x sub I delta x. When I take this limit, I will get the integral from 0 to 4, right? Because x sub I is 0 plus 4i over n. So x0 is 0 and xn is 4. So the integral from 0 to 4, 7 f of x dx, or 7 times the integral from 0 to 4 f of x dx. Now, why does this work out? So let's look at the units. 7 is in miles. Dx is also in miles because we took miles and we split it up, right? And dx was from delta x, and delta x is like miles just divided into numbers. So that's just in miles. And then f of x is in people per mile squared. So if we multiply those three quantities, we get people. So this is in fact the integral that we wanted. This will give us the total number of people who live in the city. Now this was actually originally a multiple choice question, and these were the options. Let's see what's wrong with these, if we can like say it. So this is people, I'm just gonna use P, per mile squared. This is in miles. So the end result is people per mile. That cannot be the answer. If you look down here, so this one actually has two problems. I mean, this is people per mile squared. This is in miles. So the end result would be in people per mile. But there's actually another issue with this. Here, this would have the density like vary, how do you spell vary? I guess V-A-R-R-Y, vary, changes, let's say changes as you move like up, right? Because you're splitting up your 0 to 7 instead of your 0 to 4. We wanted to split up 0 to 4, so we were moving away from the river. So this is as you move up or down. So that's a problem. It's out anyway because of the units. So the 28 here would be 7 times 4, which is in miles squared. This is in miles, and this is in people per mile squared. So the end result of this is people miles. You have one too many miles going on there. Just sort of interesting. This is the totally wrong interpretation. So the units work out, right? This is miles, people per mile squared. This would give us people, but it suffers from the same problem as this one, where we're claiming that the density is changing as we move up down instead of left to right. So you do have to, like, just looking at the units, we were able to eliminate 3 of the options. This 4th option, you have to think about it a little more. but the correct option also would have been there. So now you're just comparing those two, and I think you can definitely do that. All right, so it's all about making Riemann sums, adding things up, looking at units. I think you're gonna be fine. I'll be back in the next video to do more, so I'll see you there.